Okay, so this lesson, lesson 41, has a little bit of everything. It's all about imaginary numbers, but it's about a couple little tricks that we can do with them and how to employ them to make your life as easy as possible. Imaginary numbers pop up in all sorts of different scenarios throughout Algebra 2. So there's no way to say, like, this is when you can expect them. But here are some ways that we've seen them be used multiple times in the past. Now, first thing is with factoring. These, the left-hand column on this sheet, okay, these are all regular dots, difference of two squares. The way that you would factor something like this, difference because subtraction, is you would sort of think of it like this. Square rooting both of these, you would get x and 2. You have another bubble with x and 2. And they are 1 plus and 1 minus. Same pattern works down here, so this is going to be x and 3, and x and 4, etc. If I really want to check this, by the way, to make sure that these are equal for number 1, I could take a box method, and I could multiply x plus 2 times x minus 2, and I would find that when all was said and done, it would be equal to that right there. For the right-hand column, these are all addition. This is the sum of two squares, or oddly we are going to call it SOTS. You can tell because of the plus. So plus, 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 plus. These are all going to have imaginary numbers in it. I would love to say that I could do this, just square root both of these, right? X plus 2, x minus 2. But I can check. If I do box method, and I'll do it quick because you've seen these tons of times. Negative 4, 2x, negative 2x, and x squared. You would see that these diagonals cancel out, and I get x squared minus 4. Ah, dang. So that didn't really work. I wanted plus 4. So if I make this over here plus, and change this up a little bit, here's what I get. I get a 2x down here, and I get a 4 here. When I bring out all my terms, I get x squared plus 4x plus 4, but, wait. This and this are not equal. That's because the definition, or the rule for the sum of two squares, is that it has to include an I. Watch what happens. X times x is x squared. 2i times x, we're going to write as 2xi. Bottom right, I'm going to get negative 4. I times I is I squared. And the bottom left, I get negative 2xi. And just like before, the diagonals cancel. And what I bring out is x squared minus 4i squared. But if you remember from the previous lesson, I squared is equal to something. I squared is equal to negative 1. So if I rewrite this, it's x squared minus 4 times negative 1, which is x squared plus 4, which is exactly what we were looking for. Now I'm going to erase this. You could always jump back a second and pause right there if you wanted to copy that down. For the next one, think of it the same way. Square root and square root. So we're looking at x and 3, x and 3, but it's got a plus in the middle. That's not dots, that's difference of two squares. This has got to be the sum, which is SOTS, which is that new weird thing that we're doing with the imaginary numbers. So it's still going to be plus and minus, but we're going to need an I on the front and the back. And if you don't believe me, you should be good enough at this to check what is x plus 3i times x minus 3i? If you multiply and confirm, it should be equal to this right here. So you should be comfortable finishing any in that category. Let's do one in the bottom section, because I know you have a bunch of homework from there. Let's do question 32. I can do question 32 one of two ways. Because it's squared, I could use the shortcut, or I could use the box method. Whichever one you're more comfortable with, I say you should use, because the right answer is the right answer, and shortcuts are not always that good. If I'm going to use the shortcut, here's what happens. Negative 7 squared, negative 7 times negative 7, positive 49. Now negative 9i times negative 9i is positive 81i squared. And then we multiply the two inside, negative 7 times negative 9i. So this times this, we're going to get positive 63i. And then you need to multiply that by 2. So I get plus 126i. Now that needs to be simplified, but I'll do it in a sec on the right-hand side, because I want to show how to do it with the box method too. This is going to be 49, 63i, positive 81i squared, and on the bottom left we get positive 63i again. When I bring these out, I get 49 plus 126i plus 81i squared. I squared can be simplified. Never forget that. That becomes a negative 1. So that means this whole term here is actually minus 81. So I get 49 plus 126i minus 81. Now this and this are like terms, so I combine them and I get negative 32 plus 126i. And that will be my final answer. I get the same exact thing using the shortcut, because this becomes minus 81, etc., the same steps. Last little tricks. For the questions on the back of the sheet, you may find that you need larger powers of I. Now, here's what the values of I are. Let's clean this up a little bit. You could pause here if you really want all the work, but I already have an explanation of this in the previous video. So if you don't know why, and you would like to, please just jump back there. Now, I is as simple as it's going to get, so I equals I. I squared equals negative 1. I cubed is equal to negative I, and I to the fourth is 1. Now, we put these into what I like to call the wheel. I, so follow my cursor to see what I'm talking about, I to the first is I. I to the second is negative 1. I to the third is negative I. And I to the fourth is 1. Now here's the thing. We can count our way around the outside with all of the powers. So I have I to the first, second, third, fourth. I to the fifth would go right here. I to the fifth is also I. I to the sixth, I to the seventh is negative I. I to the eighth. I'll go one more. I to the ninth. I to the 10th. So I to the 10th would be negative 1. I could tell that from this chart. I to the 11th. And I to the 12th. Now here's the pattern you should notice. all of the multiples of 4 are equal to 1. All multiples of 4 are equal to 1. So what that means is something like I to the 40th, since that's a multiple of 4, is equal to 1. I to the 60th, 1. I to the 444th is 1. I to the 4120. Still divisible by 4, so that's 1. So anytime I want to figure out something large, what I'm going to do is I'm going to use the table and start off at the closest multiple of 4. So if you look at example number 1 on your sheet, I'll show that real quick in case you want to copy it down. This is on the back side. Or rather, we already talked about number 1 in class, so let me pick a different one with a larger power. Let's talk about question number 4, I to the 55th. So if I wanted to talk about I to the 55th, I certainly don't want to count around over and over again until I get to 55. I could, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, that's going to get really boring by the time I make it to 55, so I'm not going to do that. What I'm going to do is I'm going to look at the multiple of 4 that is closest to 55. So let's think. Multiples of 4. 4, 8, 16, 52. That's a multiple of 4, because that's 4 times 13. So 52 is a multiple of 4. So that means that I to the 52nd is equal to 1. And that also means it can be found here. So that means that I to the 52nd is here. So then I to the 53rd, we're just going to count around from there. I to the 54th. And I to the 55th. So I to the 55th is equal to negative I. So that would be the answer to question number 4. So anytime you want to take a number that has a really large exponent in the y spot, what we can do is that. So if I wanted to take something like question number 11, it's the only other one I'm going to do, what I recognize is that I to the 24th is 1. I to the 27th, let's see, let's clean up the work from the last question. So it's 27 to 34. I to 27 plus I to the 34th. Okay? So I to the 27th. What I'm going to do is I'm going to start at I to the 24th, which is right here, because it's a multiple of 4. So 25, 26, 27. So that means I to the 27th is negative I. I'm just scribbling next to everything because I can't really point because you can't see my finger. On the right hand side, I to the 34th. Let's think. Well, 32 is a multiple of 4. So I to the 32nd would go here. 33, 34. So I to the 34th is negative 1. So negative I plus negative 1. Those are not like terms, so they cannot be combined, but they need to be in a plus bi form So they're written -1 plus or minus I. And that would be the answer to question 11. Okay, if you have any more questions, please feel free to see me in office hours, and see you mañana.